Hey, CIS 281. We're team the Python Menaces. My name is Jaime, classmates Chris and Jorge, and we are gonna talk about the module 2.3, the analysis phase, specifically the video explains solutions with traditional models. Let me pull up the first one, which is the event table.
Okay. First up, we'll talk about our event table. This shows the main actions that happen in the comic track application. This is to help identify how the system responds when a user performs certain actions. For example, if a user adds a comic to their collection, the system stores the comic's title, issue number, and any notes in the database. Users can also view their collection, edit comic details, add to their wish list, delete comics, or search for specific comics as well. These events are the core functionality of the system and guide the rest of the system design that we have.
All right. Next on the analysis phase is the ER diagram. Let me just pull it up. All right, here's our ER diagram or entity relationship diagram. For our system, we created an entity relationship diagram to represent how the database will store and organize the comic collection data. The diagram includes four main entities, as you can see, which is collector, series, issue, and collection item. The collector entity stores the information about the system users, including the collector's ID, first name, last name, and email. And even though the current system is designed for a single private collector, we decided to include the collector entity to keep the design scalable should the system support multiple users in the future. Maybe the collector's partner starts their own collection, or his or her best friends start a collection as well, and they want to use the same system. The series entity represents comic book series such as Spider-Man or Batman, and stores information title, publisher, and genre. The issue entity represents individual comic book issues within a series. Each issue belongs to a single series, which is why the issue table includes a foreign key named series ID. The collection item entity represents the comics that the collector owns. It connects the collector to specific issues and store additional details such as quantity, condition, date added, and notes. We used the collection item table as a linking entity so that ownership details such as condition and quantity can be stored separately from the comic issue data. This structure allows the system to separate comic information from ownership information, which keeps the database organized and scalable. And that's pretty much it for the ER diagram.
Okay, so next up, we're going to be talking about the DFDs, the context DFD, the level 0 DFD, and the level 1 DFD. Second. Okay, so for the context DFD, it's the most simplest form of DFD that we can use. So essentially, we have three entities, which is the user, common track library management system, and the common track database. Most likely, we'll be using MySQL or SQLite 3, but that's to be determined at a later date. The whole purpose is that the user essentially talks to Comatrack, and Comatrack talks to the database through the forms of request and response, and Comatrack talks to the database through the forms of storing data and retrieving data. One thing we decided to do for our project is include the use of this comic data table. This is a little bit of a rough sketch at the moment, but essentially this is the key items of a comic. So we have the title, the ISBN, the series, the issue number, the publisher, the author, and the genre. So we're going to use the title as a primary key, or the way we sketch it out at least as a primary key. And the database is, or the data type is going to be a string. For example, for this one, we have Ender's Game. The ISBN in this form is ISBN 13. And the reason we're not using ISBN as the primary key is because it ranges between ISBN 10, ISBN 13, and some of them don't even have ISBNs, like if there was a fan comic or such. We were thinking of doing a composite key to link these tables to each other and to split up the table so that way you don't have all the information on one table and you can request by specific variables. Like if you're requesting based off a publisher and an author, if you're requesting based on multiple things. For the level 0 DFD, it's essentially how, it's a more in-depth explanation of the context DFD. So we have this user, and he has the ability to do 5 different types of requests. He can either do process 1, which is create a comic, process 2, which is modify comics, process 3, search for comics, process 4, add to wish list, and process 5, modify wishes. The reason we have create and modify in separate sections is because the logic behind it is it's similar in a sense, but it's different enough that it warrants its own sort of method. So for these processes, they are either all validated or they're all invalidated, which is sent to common track library management system, and that creates a report back to the user based on failures or successes. Common track then talks to our database in the form of read and write requests, and the database sends reports back based on which process they're using. So we only have to model for one process, but I decided to do for process 1 and 2 because they kind of go hand in hand. So for process 1, create comic, we have this user who wants to create a comic book, obviously. So he has to talk to this method right here, validate comic data, which takes in the data types such as the author, the name, the title, the ISBN, and whatnot, and it validates it so that the data is valid, obviously. And that can either go through successes or it can go through failures. If it is a failure, it reports it back to the user. If it's a success, it continues on to the common track language modeling system. Our common track language modeling system then will report duplicates of comics. So it talks to the database, and if there's a duplicate, it reports it, and it won't insert it. But it will allow the option of the user to either edit the current comic in case they wanted to change it. For process 2, we have this user who wants to modify a comic he already has. So this user will insert comic data, and it goes into this method right here, validate comic data. And if the comic data is valid, it will continue on. But if it's not, it generates a report to the user. With the valid data, we talk to comic track library management system, and we're checking if the comic that he wants to modify actually exists. If it doesn't exist, then we can report the non-existence of it, and we can prompt the user to see if they want to create that comic itself. From there, we are going to diagram B. So we've since verified the integrity and the existence of a comic. If a comic does exist, the user then will be prompted for modifications, and that goes into validate modifications to see if the modifications are valid. If they are not valid, it reports a failure, but if they are, we can then apply the modifications to the comic itself and to the database. We can update it, and the database will generate us a report, and we can send that report back to the user for errors and successes. From there, we're going to go on to the pseudocode. So for create comic, let's go back to the beginning, I guess. So we're going to be using sort of a case statement where the user is prompted with a ton of options, not through the terminal, but through the interface. If the user selects create comic, we can do a while true loop. And this while true loop is to save the valid data that they're trying to grab or create, essentially. So we're grabbing title number, issue number, author, publisher, etc. All of these variables do not need to be included, but there's going to be certain variables like title which have to be not null. They have to have some sort of data. We're trying to verify each information data. If all of the data types are integral or have integrity, we can continue on. But if not, we can restart the loop, or at least prompt the user if they want to restart the loop to insert more data. If it does exist, right, common track will talk to the database, and if it exists, we can report a duplication, or we can prompt for the user to update the item itself, actually. Otherwise, if it doesn't exist, we can send the comic data to common track, and then common track will talk to the database and create the actual comic. And then we report errors and successes to users. From here, we can escape, or we can prompt the user to create more comics. It's up to them. For modifying comics, it's much of the same, but we have to verify whether the thing exists first before we're modifying. So we're collecting data to see if it exists, first of all. If it doesn't exist, we have to report the non-existence. If it does, we can continue on and start modifications. So here we're allowing the user to choose what to modify through prompts, either the title, author, or what have you, the ISBN, whatnot. And depending on the modifications, we have to see if the modifications the user is suggesting are valid. Like if the user is trying to modify the ISBN number, but it's already been auto-generated, we want to see if that's what he's really trying to do and maybe not trying to mess anything up. So here we're going to prompt for assurance of modifications. We don't want the user to be able to delete something and not have any way of, going back or anything. So we want to prompt for assurance. If it's not assured, we're going to break and leave the comic information as is. If it is assured, then we can tell common track LMS to send it to the database, and we can show the changes through a report. If the modifications don't have integrity, we are not going to apply them to prevent any breaks from the database itself. When we have modifications that deal specifically with deletions, we're going to allow the user to select rows of comics so that they can automatically delete them. One way we decided to avoid accidental deletes is the same thing, prompts for assurance. We need the user to say that this is what they want specifically, and if it is, we can delete it. Same thing with singular, sorry. If they want to just delete one comic, they don't have to delete multiple at once. And that is our pseudocode.
All right, and that's pretty much it for our module 2.3 analysis phase traditional models. Uh, we had the event table, we had the ER diagrams, the DFDs, and the pseudocode. We'll see you in the peer review.